So hello everyone, welcome to our channel. Today we'll be solving a problem based on Fourier expansion. We are given a function f of x equal to x when x is less than 0 and less than pi. X is greater than 0 and less than pi. X minus 2 pi, x is greater than pi and less than 2 pi. Hence deduce that pi by 4 equal to 1 minus 1 by 3 plus 1 by 5 minus so we solve this. We know by the formula of Fourier expansion f of x equal to a0 by 2 plus summation of infinity to 1 to infinity an cos nx plus summation of 1 to infinity bn sin nx. We take first function x as phi of x and x minus 2 pi as psi of x. This is to check whether the function is even or odd. To check the function is even or odd, we need to look at the limits. So the limit of function is 0 to 2 pi. So we take phi of 2 pi minus x. So phi of x is x. So we replace x with 2 pi minus x. This is equal to minus of psi of x. Hence f of x is odd. Therefore a0 and an are 0. So we need to only calculate bn. Bn is given by 2 by pi integration from 0 to pi f of x sin nx dx. We replace f of x here, 2 by pi integration 0 to pi x sin nx dx. We take x as it lies in limit 0 to pi. So we then integrate this using the formula 2 by pi, keeping the first term as it is, integrating the second term, then differentiating x and integrating this term, all to the limit pi by 0, pi to 0, 0 to pi, and this term gets 0 as both sin n pi and sin 0 are 0. So only cos term remains. We get this as 2 by pi n pi cos n pi. X is done as pi. Then we take the value, pi gets cancelled, cos n pi is given by minus 1 raised to n. So we get this as we take minus common here and multiply it with this one, so it becomes 2 into minus 1 raised to n plus 1 by n. Next we deduce the given expression, pi by 4 equal to 1 minus 1 by 3 plus 1 by 5 and so on. So we put this in the formula, summation of 1 to infinity bn sin nx. This is the bn term. We take x as pi by 2, then pi by 2 equal to, we take 2 outside it as its constant term, summation of infinity 1 to infinity minus 1 raised to n plus 1 by n sin n pi by 2. 2 comes here, so it's pi by 4, and for every for n equal to 1 we get minus 1 raised to 2 by 1 sin pi by 2, which is 1. Sin pi by 2 is 1. 1 into 1 is 1. When we take 2, so minus 1 raised to 3 by 2 sin 2 into pi by 2. So sin 2 into pi by 2 is sin pi, which is 0. So we don't get it here. Next next we take 3. So minus 1 raised to 4 by 3 sin 3 into pi by 2, which is minus 1. So we get a minus term, minus 1 by 3. And for every even term we get a 0, and for every odd term we get a value here. So we get a positive and a negative value. So this keeps continuing.